Okay, we're going to look at solving right triangles. Now, really, all solving a right triangle is maybe you're given an angle measurement and a side length, or maybe you're given two side lengths in a right triangle. Okay, and you're asked to solve for all the unknowns. That's just known as solving a triangle. Okay, so again, we're finding the unknown measures, round the lengths to the nearest hundredth, and angle measures to the nearest degree. Okay, so let's take a look now. Let's look at what we're actually given here, right? We're given two side lengths and the fact that it's a right triangle. So I know this here and I know this here, right? So let's maybe write out our SOHCAHTOA and see maybe what would be helpful here, right? So maybe if I look at this as, I don't know, maybe angle, let's look at this as angle R, okay, through the lens of angle R. Okay, I know an adjacent side, and I know the hypotenuse. So this is what I'm looking at. I'm looking at cosine. So what I could say here is I could say the cosine of R is going to be equal to, well, the adjacent side is 5 over the hypotenuse, which is 5.7, right? Okay, well, if I actually know that ratio of the cosine of R, I should now be able to figure out what the angle measurement is. So if you can imagine here, I'm basically almost like dividing both sides by cosine, and that's really going to end up with the inverse of cosine, and that actually gives us the angle measurement. So I can write this as the measure of angle R equals the inverse cosine of 5 over 5.7. Okay, and so this is what we have. Now, if we plug this into our calculators here, we'll maybe find the quotient of 5 divided by 5.7 here first, okay? And we'll end up pressing the inverse button, then the cosine, and we get, we'll do a little rounding. We actually have to round this one up. So I get the measure of angle R equals 29 degrees, okay? And so that's helpful, right? We found something that we know, that we need to know. And so here we go. I get 29 degrees for R. Okay. Now we learned last semester that the acute angles of a right triangle are complementary, right? So I'll write that down. I'm going to write down the acute angles of a right triangle are complementary. Okay, so that would mean this. That would mean that if I take 90 degrees and I subtract the measure of angle R, that would give me the measure of angle T. All right, so if I took 90 minus 29, that would give me 61 degrees. All right, so I'm now going to say that the measure of angle T equals 61 degrees. Okay, so there's one answer. Here's my, I suppose I forgot to circle my other answer. And now I'm interested in finding ST, okay? There are a couple of ways we can do this. I'm going to do the easy one first, maybe the most less confusing way, okay? I'm going to put this as 61 degrees, okay? And I'm just going to use the Pythagorean theorem here because I know two of the side lengths. I know one leg and the hypotenuse, and so I'm going to write this as the Pythagorean theorem. So I'm going to say that ST squared plus SR squared equals TR squared, okay? And so this is, when I plug in the numbers, this will give us ST squared plus 5 squared equals 5.7 squared, okay? And I continue to keep going, right? So ST squared plus 25 equals, I'm going to go ahead and find my calculator here for 5.7 squared. Okay, and I get 32.49. And I'll now subtract 25 from each side to get that ST squared equals, I get 7.49. And then if I take the square root of both sides, only taking into account the positive value here, I end up getting that this is 2.74 by rounding, so 2.74, okay? And that is my measurement of ST. So technically at this point we have solved all the problems, or everything that they have wanted us to solve. Okay, there is another way that we could do this. Okay, we could use trig ratios as well here. Okay, now remember this 29 degrees and 61 degrees, those are rounded values. Okay, they're not necessarily exact. And so we need to be very careful when we do this using trig ratios. Okay, but what I could say here is that maybe, for example, the sine of 29 degrees is going to be equal to ST over really TR, but I know TR, right? So because it's an opposite over hypotenuse for sine, so I'm going to write this as 5.7, right? Actually, sorry, I'm not going to write this as 29 here, so forgive me for my mistake. I'm going to write this as the sine of R, okay? So the sine of R, however many degrees R is here, the sine of R equals ST over 5.7, right? Because 29 was not an exact value here, okay? So what I'm going to do now is multiply both sides by 5.7. So it's going to be 5.7 times the sine of R, and that's going to give us ST, okay? Now remember, for R, what the actual angle measurement was, what we plugged into our calculator was over here, and that's in red. So if I want to find ST, I could say ST is going to be equal to the sine, or 5.7 times the sine of, well, to find R, the measurement of angle R, we plugged in cosine, the inverse cosine of 5 over 5.7. Okay, so if we plug this into our calculator, okay, we would actually get the proper value for ST. We would still get 2.74. Okay, so don't let that last part confuse you too much, but just know that there are multiple ways to solve the problem.